I'm Konstantin, the CEO and founder of Blockdaemon. We're the largest institutional infrastructure provider in crypto, and so what that means is we run around 185,000 nodes across 70 data centers around the world, really providing access for institutions to send transactions through the respective protocol networks. And so we're in the business of abstracting away complexity for infrastructure and wallets for institutions. What's a little unique about us is we've been around for a few years, and we're the most institutionally backed crypto company. We have 3 of the top 10 global banks as major shareholders, which is JP Morgan, Goldman Sachs, Citibank. And our customers are similarly sort of institutional. They include the Fidelities, the Bank of New York's, the people on our cap table, the PayPals, the Robinhoods, and so forth. The reason I mention it is because today what I'll talk about is a little bit like sort of the next kind of trend that we see in the institutional ecosystem currently. And so, and before I do that, I also want to mention that we open an office and have a license here in Dubai, and so we officially got that done yesterday. And so we're very excited to be here and talk to folks. So next slide, I'm gonna show you a little bit what L2s actually are. People talk a lot about stuff, and so I think it makes sense for people to understand what L2s are. If you're in the space, you probably have heard about them. L2s really deal with originally the problem that Ethereum has with transaction throughput, right? And so there was always a lot of talk about how many transactions can you really actually put into a block. And so what has happened is that you had networks and frameworks created that allow people to build chains on top of chains, right? A layer 2. And really all that one of the key component of the layer 2 is that they can bundle transactions and then submit one transaction to Ethereum, but then behind it have a box of 10 transactions. And so as an example, so it's sort of like kind of 10x the transaction volume that you can do on Ethereum, and it all happens sort of on chain. There might be a slight delay, but it all happens on the Ethereum chain. The other thing that these frameworks make very exciting is that you can kind of dictate the rules of the framework a little bit, right? And so in this example, we're looking at the Optimism stack. That's a very popular framework solution. The Base project is built on it, the Coinbase L2 that, I mean, if you're not familiar with it, check it out. It's probably the most significant development that Coinbase has done in a very, very long time. And the goal really for Base, for example, is to have every transaction that Coinbase processes to actually be locked on the respective chain. And so, and that's a good example of a proprietary chain or L2 in some ways, right? And so Coinbase obviously stresses the importance of this being open source and being a sort of public good. But that said, you know, they're not just doing it out of the goodness of their own heart. They're developing an application ecosystem that supports the functionalities of their exchanges. And then there actually fund commercial models underneath these L2s, which is you can operate sequencers and generate fees for the transactions to be processed. And so so every transaction that gets bundled and pushed through Base, Coinbase operates a sequencer and generates fee earnings on it. And so the reason why I mention it, because that's why Blockdaemon is so interested in that space. We've been, you know, really spearheading the outsourcing and development of node infrastructure for institutions. And for us, a lot of the work now is in the sequencer ecosystem for institutions. And so that's interoperability, bridging chains across chains, so translating transactions across multiple chains so they remain on chain and can get settled on chain. There's a bunch of others that you see on here. They're kind of all the same and all a little bit different. Some of them have a token, some of them don't. They serve different purposes, but that's sort of the main piece here. The reason this kind of always find interesting, it's just interesting to see how much volume actually now occurs on these L2s compared to actually Ethereum. The blue line here is the ETH, and then the red line is a bunch of the L2s, the Arbitrums, the Bases, and so forth. And so you can see that there's so much value getting locked in, and it's becoming a much more common way to submit transactions. And so that's why it's a very trendy subject, right? And so that's why a lot of people talk about it. And so there's some benefits and drawbacks. The big benefit is that you're ultimately referring back to the decentralization, and I'm air quoting, of Ethereum here in terms of security, right? So it gives you some sort of a particular framework that has more throughput, but still has to go through the Ethereum network. And so there's obviously lots of different people running nodes. There's lots of debates and how decentralized Ethereum is, but you're sort of borrowing from the security of the ETH network running an L2. You're really aligned, obviously, with Ethereum. One of the big subjects, too, because we're in the protocol abstraction business, is EVM chains are very popular to build and develop on, mostly because when you want to we develop APIs for exchanges and stuff, for example, that are cross-protocol. Anything that's not EVM is very, very difficult to abstract away. And so by definition, there's a lot more efficiency around abstraction if you can focus simply on EVM. So some of our sort of adjacent competitors like Alchemy only support EVM chains, for example. And so they're just we're not touching anything that's not based on Ethereum. It's just too much work. And so those are, and then some drawbacks can't be forked. There's compliance issues because ultimately you do default back to the validator set on Ethereum. And that's going to be always an interesting problem when we talk to institutions, because what they need to make sure is that wherever their respective block lands and the node that processes and validates the transaction can't be a node that really validates a transaction that comes from a non-KYC entity. And so there's actually a lot of interesting conversation on how does that happen technically on proprietary mempools and things like that. But I don't want to bore you too much with it. And so I'm going to do some of this quickly because it's a little obvious. Obviously, why is this so interesting, and why are companies thinking about their own L2? So in the bull run of 2017 and 2018, you had lots of proprietary networks being built, like permissioned networks, right? And so you had Hyperledger, you had all the big banks. Everybody was thinking about R3, for example. Lots of different projects tried to tackle and bring blockchain technology to institutions who could not have an open network because they need to know and AML and KYC every participant in a network. And those projects mostly failed, mostly because the whole benefit of a network is openness, right? And so one of the key things that has evolved since then is that these purely permissioned networks were too closed off and just lacked a lot of the innovation and functionality that these open networks can now bring. And so now you have a sort of interesting opportunity to kind of have a little bit of both worlds with L2s, right? And so lots of banks and companies are thinking about, hey, do I want to build my own proprietary L2? And then I can control who has access to that respective L2. It's closed, but it falls back on Ethereum, which is ultimately a public chain, right? And so it's sort of a little bit of a hybrid approach that allows them to take advantage of the development in the Ethereum developer ecosystem, as well as controlling the in and outs of their respective permission network. And so it's an exciting time in a way, because that type of interoperability in permission chains didn't work, but here we see an opportunity for institutions to get engaged and benefit from the open source nature of Ethereum while retain certain degrees of control. And so, and then on top of that is another fun layer, which is L3s. So you'll hear a lot about those. So you'll have Ethereum, then you have Base, and then JP Morgan could say, and then we have the JP Morgan chain, and they kind of sort of just ultimately lock transactions through each other. And so institutions can develop, they can develop L1s if they want to. They can do L2s, L3s. So you're going to see all these different layers and use cases. The Base folks would say, oh, they all need to do L3s on top of Base, and then institutions might say, hey, wait a minute, you control the sequencer and make all the money. We're going to build our own L2 because we want to control the sequencer and make a little more money. And so it's an interesting development that we see that will help us bring institutions into the crypto fold a little more openly than we did in the past. Use cases, fairly obvious. Payment is a really good one. Paymaster applications, wallet applications are getting a little better. We're very focused on the sort of wallet lens for which we look at abstraction, mostly because wallet stacks are still pretty poor. And so there's lots more work to come, but I think that also creates a lot of opportunities, specifically on payment and stablecoins. Obviously, tokenization, on-chain finance. I'm sure you guys have heard of some of them. This is kind of going back to what I initially said. It's sort of like, just interesting also maybe for folks to know really what blockchains do. They read and they write, right? So you read and look at the transactions, or you write the transactions. And so that's really kind of what it looks like, right? It's like a spreadsheet that sort of has an account and says, hey, this guy sent a token to here, and you can look up a transaction, or you can submit a transaction to be added to the sheet. And those are really the two functionalities. And the point I was making about the hybrid nature here is that the big thing is that on the read side, you can make these permissioned networks open. On the write side, you make them closed, right? So only people who are, for example, KYC submit a transaction into it. This is all the kind of fun stuff that an L2 needs, which is why we like them, right? Like ultimately, we benefit from protocol proliferation as an abstraction provider if they are based on an L1 that we can easily replicate and build APIs for. And that's really all around how they batch transactions. And so it really, like, when you have 20, 30 different protocols you try to offer services for, then you need to understand all the different epochs, how many transactions go where and when, and you need to kind of submit all these transactions through the same interface, and that can be pretty gnarly. And so, let me see. And so, a little bit about Blockdaemon. I don't really want to shill too much here, but kind of so the two big trends in infrastructure, or three that we currently see, is one relates to MEV that if you're in the space, you'll probably hear about. That's a way how you can monetize infrastructure by providing really fast and efficient transactions and opportunities to folks, so you get rewarded. There's the roll-ups, the L2s and L3s that I've mentioned that institutions are creating. And then there's account abstraction that's really important for ultimately smart wallets, right? Like, so you want to make sure that people can onboard and do things really quickly and easily. And smart wallets are a great way to do that. And so those are all the things that Blockdaemon does, right? And so we do account abstraction and smart wallet technology for institutions like the JP Morgans and the NASDAQs. We do the roll-up stuff. We're very involved with Base, for example. For a long time, we thought about building our own L2, but we figured, we're really just a solution provider. We don't really want to have the ownership of a chain. And so, but we're very involved in also creating others for institutions. And then on MEV, it's really a staking-related yield optimization product. I have a minute left. So, this is a nice little slide, lots of errors. Kind of says interoperability is important. The main point I'm trying to make is that a network in silo isn't really a network, right? And so interoperability is really important. And the next generation of interoperability is all around on-chain swaps, DeFi, all that type of stuff that's getting really juicy and exciting for people, because there's lots of opportunities to generate value with it for a lot of different stakeholders. So commercial models are constantly shifting in the infrastructure stack, and we're really excited to see it. And so with that, I'm going to say thank you and give you 21 seconds back. So there you go. Huh?